Hi there. Hope you have a fantastic day today. This lesson, I will teach you how to solve problems involving optimizations. Of course, there's a PDF versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one. So first of all, we know that AHA has 100 meters of fencing. And he wants to construct a rectangular garden. So that is rectangular garden. And we need to work out the dimensions that will give us the maximum area. So first of all, we know that the fencing is 100 meters. That means P is 100 meters. And let me just draw a diagram out first. So it's a rectangular garden. So that is, let's say this is X, the length of the garden is X, and the width is Y. And to work out the perimeter, so we go 2X, because this X at another X is 2X. So let me just write on here, P is 2X. And then we add this Y and this Y, so 2Y. So P is equal to 2X plus 2Y. And we know that the perimeter is 100. So we put 100 is 2X plus 2Y. So now we can either make X as a subject or Y as a subject. So let me just make Y as a subject. So what I do, okay, I just move X on one side. So X move on this side becomes minus 2X. So that is 100 minus 2X is equal to Y. Then I divide by 2 on both sides. So that means divide this by 2. This, we divide this by 2. They cancel out. So let me just write out here. So that means Y equal. So what I do, I take out the common factor for this. So 102. So the common factor is 2. I take 2 out. So 100 divided by 2, it gives me 50. And 2x divided by 2 is x. So that is minus x. And divided by 2. This cancel out. So therefore, y is 50 minus x. So there you go. So now to work out the area of a rectangle, that means length times width. So that is area is x times y. And we know that y is equal to 50 minus x. So that means equal x 50 take away x. And if I expand it, so that would give me a equal to 50 x and minus x squared, which is 50 times x is 50x. X times negative x is minus x squared. So that is the area of the rectangle garden. Okay, keep that in mind. So now we need to find the dimensions that give us the maximum area of the rectangle garden. So to do this, so to work out the maximum for the area, so we just differentiate this and make it equal to 0, and we solve for x. Okay, just like finding these stationary points. Okay, and then we test it and make sure it is maximum. So let me just differentiate the area respect to x. So dA dx will give me, differentiate 50x, give me 50. And minus the derivative of x squared, give me 2x. And then to work out the maximum area, of course, the derivative of a respect to x is equal to 0. Okay, just like finding the stationary points. So dA dx is 0. So this means that 50 minus 2x is equal to 0. And to solve for x, I move this on this side. So that becomes 50 equals, so negative 2x, we move on this side, becomes positive 2x. So that is 2x. Then I just divide this by 2. And I divide this by 2. So therefore, 50 divided by 2 is 25. So therefore, x is equal to 25. So when x is equal to 25, so we need to test it to make sure it is, give us the maximum area. So we know that dA dx is equal to 50 minus 2x, okay, from this gradient function here. And then if we differentiate again, because we want to test it, whether it's a maximum or minimum at x is equal to 25. So differentiate this again. D square a dx is equal to negative 2, which is less than 0. So that means it is maximum. So you got therefore at x is equal to 25, the area. So there you go. So we need to find the dimensions. So when x is equal to 25, so when x is equal to 25, y is, so we have the equation here earlier, 50 minus x. So y is equal to 50 minus 25. So that gives us 25. So there you go. We have x and y. That is the dimensions of the rectangular gardens. So therefore, 25 meters by 25 meters. And the area is, so we go 25 times 25 will give us, so just go 25 square. So there you go, 625. So 625 square meters. So there you go. Please pause the video and try this one yourself. Hi there, I'm back. How did you go? Let me go through it with you. Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So first of all, we know that the playground is a rectangular shapes, and we know that the perimeter is 120 meters. So let me just draw the diagram out. So we have a rectangular playground. So let's say the width of the playground is x, and then the length is y. And the perimeter of this P is equal to, we have x and x, so 2x. And we add the length, which is y here, and y here, which is 2y. And we know that the perimeter is 120 meters. So P is 120 is equal to 2x plus 2y. And I can just take our common factor on the right hand side. So that is 2 bracket x plus y. And this is 120. So if I divide this by 2, and I do the same thing on this side, this cancel out. Let me just move this up a bit. So this means that 60 is x plus y. And to make y as a subject, of course, you can make x as a subject as well, but easier if we make y as a subject, okay? So you move this on that side. So 60 minus x is equal to y. So therefore, we know that to find the area of the rectangle here, so A is x times y, length times width. So I is x, y. And we know that y is 60 minus x. So that means I is x times 60 minus x. So that is y. And this is y here. Now what I do, I just remove the bracket. So 60 times x is 60x. X times negative x is negative x squared. So that will give me, this is 60x. And this is minus x squared. So that is the area of the rectangular playground. So what we do next is we need to find the dimensions of the playground that give us maximum area. So to work this out, we just need to differentiate the area and make it equal to 0, and we solve for x. So now dA dx is, we differentiate 60x will give us 60. And differentiate x squared give me 2x. So minus 2x. And the differentiation of a respect to x is equal to 0. So this means that, so dA dx is 0. So this means that 60 minus 2x is equal to 0. And we just move the negative 2x on this side becomes positive. So 60 is 2x. And I divide by 2 on this side. Divide by 2 on this side because I solve for x, okay? So therefore, x is equal to 30. Now we need to test it to make sure when x is 30, it gives us the maximum area. So we know that dA dx is this. And then now we differentiate this second derivative. So d squared a over dx squared is negative 2, which is always maximum because less than 0, which is less than 0. So therefore, it is maximum always, okay? So now just write therefore, maximum at x is equal to 30. So when x is equal to 30, we need to find the y value, that is the length of the rectangular playground. So we need to substitute here 60 minus x. So that means y is 60 minus 30. So that will give us 30. So therefore, the dimensions of the rectangular playgrounds are 30 meters by 30 meters. And the maximum area is equal to 30 times 30. That will give me, so 3 times 3 is 9. And we need to add 2 zeros. So that means 900 square meters is the maximum area of the rectangular playground. And the dimensions are 30 meters by 30 meters. And I hope you got it correct. Thank you so much for watching. Bye.